Hello, welcome back to Cracking the Cryptic, and we'll be streaming tomorrow night. So do join us then into the Blueprints house, into the kind of draft Blueprints house behind the Blueprints house. I don't know what's going on, but it's a very interesting map making exercise for me, and do join us. We'll see how that goes tomorrow. Do join us in chat. It's always a fascinating discussion going on there. And it'll be great fun to have you with us. That's 10 p.m. our time tomorrow evening. We've also, of course, got all sorts of things going on, as well as the regular channel. 2 Sudoku videos a day, 1 minute cryptic, 1 Wordle in a minute, every day, all of those. And then on Fridays, we do a cryptic masterclass, and we love it if you learn about cryptics from that. But we've got more cryptic videos on Patreon, so do check that out, along with connections and gridogram videos. We play that every day as well. And coming on, it's in 3 days' time, Detective Pets by Sandra and Nala and Panthera, a brilliant Sudoku hunt. Please join us in time for that. It's going to be great fun. And that the clue is in the title, really, as to what it's about. But we look forward to giving that a go. We've got apps as well, which do feature line Sudoku, very relevant to today, and classic Sudoku 2 and the Worms. So check those out. And we've got a bit of merch as well. If you were interested in that, do buy some Cracking the Cryptic gear and look cool. It is a little cooler here, finally, thank goodness. It's taken a while to get to that, but maybe I won't be actively sweating on camera today, or maybe I will. And maybe that will happen because of Half-Baked Lunatic, who we used to do regularly on the channel and is now no more than quarterly, which is a disappointment. Maybe I'll try and increase that number. But this puzzle is called Just Some Long Lines, note the pun there. And the rules I will do now. Normal Sudoku rules apply 1 to 9 in every row, every column, and every 3 by 3 box. And then box borders divide a blue line into segments with the same sum. So that pair will equal the same as those 3 and those 5 cells, and so on. For that, there's basically an outer line and an inner line in this puzzle. Right, I am going to start now. So do try it on that first link under the video, which will take you to play the puzzle in our software. I'm going to start now. Let's get cracking. And let's use that 2-cell versus 5-cell comparison. The minimum for 5 cells in the same box is 15. 1 plus 2 plus 3 plus 4 plus 5. The maximum for 2 cells is 17. So the n for this line is somewhere between 15 and 17. But hang on. We've got 2 bits of the outer line in this box. And suddenly we said 15 as a minimum there. Now I'm going to say 15 as a maximum, because 4 cells that all have to be different can maximally add up to 30 by being 9, 8, 7, 6. So that's what's going on. We've got a 9, 8, 7, 6 quad, a 1, 2, 3, 4, 5 quintuple, and the n on this outer line is 15. It could be 15 on the inner one as well, but I haven't really examined that yet. But we do know that for the outer one, it's 15. So again, down here, we have a 5-cell segment. Might as well color it purple again. That's 15. No more 2-cell segments on the outer line. They're all 3 or 4. Which are a bit less conducive to knowing what's in them. Right, I'm going to put in 1, 3, 4, and 5 here, just in case it yields a quad or a quint somewhere, and it doesn't. That given 2 takes 2 out of a few little cells. That given 3 is doing nothing. Okay, let's have a quick look at the inner line. 2 cells, 2 cells, 2 cells, 3 cells, 2 cells, 3 cells, 2, 2, 3, 2. That is not very helpful. Okay, here's the first. Well, no, I mean, once it's 3 cells, the minimum pairing on this, or the minimum n for this line is 6. Now, I'm going to compare blue, green, and orange there. And I think none of these pairs can be the same because they would clash. So this must be three. If orange tried to be the same as the green pair, we'd have three greens in a column. So there have to be three different ways of expressing this total of two cells. Now, unfortunately, that only raises the minimum n to 7 from 6. But it does reduce the maximum n from 17 down to 13. 14 can only be made up two ways, 9, 5 and 8, 6. So n is now somewhere between 8 or 7, between 7 and 13. Oh, and there are 3 pairs in the central box and they don't include a 3. So now I can rule out 7 and 8. 7 has 3 pairs that are 1, 6, 2, 5 and 3, 4. 8 has 3 pairs that are 1, 7, 2, 6 and 3, 5. So now we're looking somewhere between 9 and 13 for the n of the central, of the inner line. But that's still not very constrained. But maybe we can look at the whole box total. So yes, here we had 15. Right, these two cells, oh, they're from 6, 7, 8, 9. Right, well that has, oh, well there we go. That's going to do it. These add up to a minimum of 13, but we also said that was the maximum from 3 different pairs. So n is 13, and that's a 6, 7 pair for the inner line. And these green and orange, they're the other ways of making up 13. One of them's 8, 5, and one of them's 4, 9. And now we know 13 is the n. So this group of cells don't include 1 and 2, basically, because they can't go into 13 pairs. The trio here is 13. The trio here is 13. If we add the 15 on the outer line, we get 28. Oh, and then these other 3 cells, or these other 3 cells, or these other 3 cells add up to 17. Ah, these other 2 cells add up to 17. Oh yes, this is exactly analogous to that. I could colour that blue because it's a 6, 7 pair. And now those are 8 and 9. So here, this box is, both boxes 3 and 6 are slightly different, are they? We've got a 2 cell and a 3 cell bit. So those 4 cells now add up to 17. That's not actually very helpful. And here, this pair adds to 13 and 4 cells add to 15. Well, again, we have 3 cells that add to 17. No, that's not that good. Right, let's look at that 6, 7 pair. Take them out of those cells, which are now an 8, 9 pair. This pair are now a 6, 7 pair. And we have 6 and 7 strung across row 7. We're going to need another, this digit from 8 or 9 is in one of these 3 cells. If it was on the 13 line, the other cells would be quite small. But not maybe crucially too small. Oh, these cells in this column, they can't be 6, 7 or 8, 9. So there, these have a maximum of 9, I suppose, a 5, 4 pair. They can't be that because that would make this a 4 on the 13 line and we'd have 2 4s. They can't be 5 and 3 because then we'd have a 5 here. So they add up to no more than 7, and this digit is at least 6, but it can't be 6 or 7, so this must be 8 or 9. And now these two add up to either 4 or 5, so they don't include a 5. They're either a 1, 3 or a 1, 4 or a 2, 3 pair. And this digit, I'm tempted to start colouring 8s and 9s. Oh look, there's an 8, 9 there and 1 in this pair. Right, I'm going to hash those. So there's an orange 8 or 9 there, and I'm going to say there's a green one there, just as there's a green one in one of these cells. And that's an orange one. I don't know what digits these represent. That's a green one, but now this digit can't be green. It can't be the 8 or 9 here. So this one must be. And that was quite useful. Now I can place that green 8 or 9 in row 4. And that is on a 13 pair. So this digit is 4 or 5. And in fact, it's the same as this one, which is also on a 13 pair. What colour do I give them? I'm running out of colours. Red, I suppose. That one's the green. I don't know how these are going to translate as green and orange. And I don't know which one of these is which, but green and orange are both here. What does that do for orange? Oh, orange is there. Orange is in one of these. Don't know. 6, 7 pair in this box. Don't know much about that either. 3 has now been stopped from being here. So 3 in this column might well be on this Z pentomino, but it might not. Now we've had the 8, 9 pair in this column, so everything else is from 1, 2, 3, 4, 5. And now we've got a 1, 2, 3, 4, 5 quint in the box. So these are from 6, 7, 8, 9. And this line has to add up to 15. So if we were to put a 9 in one of those cells, we'd break it. 9 and 6 at a minimum is already 15 with a cell to go. So this is either 6, 7 or 6, 8 with a 1 or a 2 to complement it there. So one of those is a 6, and now this digit is not a 6. Does one of them have to be high? No, I don't think so. 6, 8 is the only way to do it with a 1 there. I can't see. Would that have implications for everything else? Not sure. That was interesting. Have we got an equivalent discovery to that? Is this line similar? No, because that was a 15 segment. This is a 13 segment. But no, this is easy. This can only have 1 high digit on it. No, it can only have 1 high digit in those two. It can only have 1 high digit on it because it's a 13 segment, actually. Yeah, I don't know what that means. Right. Let's try and find something else. It's going quite nicely when I was finding these green cells. I'd love to resume a bit of that. There is an orange in one of these 3. This is a 15 line they're on, so can it? Yeah, I think one of these could be orange. It's not too difficult in terms of the putting together the sum here. These 3, I mean, these 3, these 2 can't be 8 or 9. It was more interesting when I could force 2 of them to be high over here. That was where it got interesting. I want to force them to be high rather than force them not to be. Oh, look, there's a 1, 2 pair in the middle row. So this digit is not 1 or 2. And now this is the 13 line, isn't it? This bit, it is. So the minimum there is 8 and 3. That's 11. This now has a maximum of 2. So now we're getting 1s and 2s. So I'm going to have to find some different colouring. So I'm going to get rid of my pink colouring so that I can reuse pink. And indeed, I'm going to get rid of that colouring down there. So I can reuse these colours. I'm going to use pink and grey for 1 and 2. Because they are starting to form in rows 4 and 5. Now we're going to need a grey somewhere here and a pink in one of those two. Pink there. It didn't go very far, did it? Oh, now, hang on. There's something going on here. Doesn't 8 have to be included here? Because either one of these digits, no, one of these digits is a 2. If this one is a 2, that is 3 and 8. Oh, then this, I think that breaks down. I think it breaks down within box 4. If that's a 2, this has to be 3 and 8 to add up to 13. And then that's a 1, and that requires this to be 6 and 8 to add up to 15, and you'd have a repeat 8. So grey is actually a 1. Is this my first digit in the grid after 13 minutes? It is. But it's 4 digits all at once. Now, the 2 here must go with a 6-7 pair to make 15. And that means this digit is not a 7. And I can colour green versus orange there. Now, this pair adds up to 12, so I don't know what they are. I don't know whether they're 8-4 or 9-3. Or do I? This pair adds up to 13, obviously, and that means this pair adds up to 13. Now, that might have ramifications here. If that's 9-4, over here we have 8-3, and then we have 3-9-1. Oh no, that's fine. So what if this is 8-5 instead? Then that's a 9, that's an 8, and this is a 4. Oh, bother. Well, that looks like it works fine. So, so I don't know where that leaves me. I mean, I think it leaves me unresolved, basically. So there's a 2 in one of these cells. Let's do some ordinary Sudoku. There's a 1 in one of these 3. Those aren't huge conclusions, but the 6-7 pair here. No, I don't think it's doing anything, but it was nice to get a 2. Oh, that's a 2 by Sudoku in column 3. Right. That's an unexpected find. This can't, neither of these are 2 or 3 actually in this row, given the given digit. Oh, does that mean this is the only place for 3 in the box? Oh, it's really simple, isn't it? Sorry. For some reason, it's harder to see the black digits that are there already than the blue digits you write in. I never know why that is, but this is a 3. Now we can add up this segment. We need a 9, and we've discovered what is orange and green. 8 is orange, green is 9. This is an 8-5 pair now. That red digit is a 4 to make the 13s work. This has become a 4-5 pair. That's been available for ages. Again, hadn't seen it. No excuse. Now, one of these is an 8-5 pair and one is a 6-7 pair. Oh, this is not a 6-7 pair, or that would break. So this is an 8-5 pair. This is a 6-7 pair. This row needs digits from 5, 6, or 7. I think we're going to have a very low digit here. Oh, there's a 3 in one of these two cells. These are a 2-3 pair, so we're going to get a very low digit here. The maximum of these is 10, the minimum is 7. That puts this somewhere between 5 and 8. It can't be 5 because of the 4-5 pair, so it's 6, 7, or 8. It's not 8 because of the 8-9 pair. So now I've got a 5, 6, 7 triple in the box, and these are 1 and 8. And now I'm going to start colouring 6s and 7s against each other. So let's get rid of the blue and go blue and yellow. Now, can we put 2 6 7s there? Yes, actually we can. Can we have a 5 here? Yes, if it was 753, that adds to the right number. So my colouring sort of, oh, well, maybe it doesn't fail. Hang on. One of these is blue. No, it does stop there. I don't know what sort of 8 or 9 that is. There is an 8 in one of these 3 cells. It could be on the line, or it could avoid it. This trio adds to 13. I don't know much about them, if I'm honest. Nor this diagonal trio adding to 15. But we're still making progress, and I'm feeling confident about the puzzle to a degree. I mean, the degree may end right here. 2, 6, 7. So these are not those numbers. They can't... I was going to say they can't both be from 1, 3, 4, but even that's not true. They could be 3 and 4. Yeah, I don't know. That's not a good area to be. Okay, I'm going to colour this, but I don't know whether it's yellow or blue. So I'm going to get rid of red and green. How about that? Might get rid of orange as well, because it's sort of done the job. I'm going to colour this orange and this red. This is orange, this one's red. Now, the reason I'm doing that, I don't know whether orange and red will translate to yellow and blue at some point, but I can't achieve that translation until I can map them at least by column here. Now, I do know these digits can't be 6 or 7 at all, because they see 6, 7 pairs in their row and column. So orange is in one of those 2 cells, and red is in one of those 2, and neither's on this line, which is going to have to achieve 13 without using 6 or 7. And that is interesting. It can't do it from lower numbers alone. Yes, that is true. It cannot do it from lower numbers alone, because the most you could get is 3 plus 4 plus 5 equals only 12. So it must have one of the digits from 8 or 9 here. And that digit is not sitting here, which sees an 8-9 pair in the row. So it's in one of these 2. There's an 8 or a 9 here. So I'm going to add a completely new colour scheme of light blue and, well, let's get rid of grey there and use grey here. And hopefully I can map light blue and grey to the 8s and 9s I already have when I get going. But again, there's a grey in one of those 2 cells because we need an 8 or 9, and there's a light blue in one of these 3, and I don't know which one. But there's a grey 8 or 9 here, and the digits it's going with, if it's a 9, it has to be a 1-3 pair, and in that case it would be 9 here and 1-3 here. If it's an 8, then the pair's either 2-3 with a 2 here and the 3 over this side with the 8, or it's 8-1-4. That one couldn't be 1, and this one can't actually be 8 or 9, so the 4-1-8 is the thing I'm allowing now. I mean, that constrained these digits a bit, but really not quite enough. Okay, let's have a quick think about this 15 line, just in case we could force the 8 or 9 onto it. I don't think we can, because it could have a 6 or 7 on. So it doesn't need an 8 or 9. It can only have one of 6 or 7 on it in that position. If it didn't have any, it would have to have one of 8 or 9, which would be this one. So either that's 6 or 7, or that's 8 or 9, or possibly both if it went 8, 6, 1. And the trouble is, I don't think I can answer that. can't say that's wrong. I don't know. I don't think I can. Yes, I can actually. That is wrong. 861 is wrong because no, I can't. I was going to say that would be the same as this. That's not right. This would be the light blue one. Now, I don't know. That line of inquiry petered out, I'm afraid. So maybe I should be thinking about this 15 group. I just don't know much about it. Doesn't have an 8, or it doesn't have an 8 anywhere on it. I mean, that's not very interesting information. It could be 9, 1, 2, 3 if the 9 was here, and these could be from 1, 2, 3. Okay, let's say it didn't have a 9 or an 8. Can't have both 7 and 6 by the virtue of being 13. No, I don't know. I mean, I think there are still too many possibilities to really work on that. So is it this? This is a 13 line. And this is a 15 line. Which one of those is more useful in box 2? I just don't know the answer. Okay, this digit sees 9, 5, 8 in the row, 3, 1 in the column. That is 2, 4, 6 or 7 in a 15 line. So maybe that is going to address the question of whether 8 can be in one of the line cells here. 8, 2, 5, 8, 4, 3, 8, 6, 1. They all look painfully possible. Gosh, yeah, I don't know. Wow, okay, I didn't get very far there, I admit it. Right, there's a 9 in one of those cells, so there must be a 9 in one of these two. Now, it would be very interesting to force the 9 to be there from this point of view. In fact, 9 is in one of those two cells, and either of them is quite interesting. 9 being here is very prescriptive for this line. This line would have to be 9 there, a 1 or a 3 there, and digits including a 2 from 1, 2, 3 here. That would make this 3. So for this to be a 9, this line would go 3, 9, and a 1, 2 pair. And that's very constricted. For this to be a 9, this is a slightly more complicated vision. These 3 now have to include 9 and 8, and that means you can't hide them both off the line. So one will get onto the line. And if it's a 9, the other two cells on the line are either 2, 4 or 1, 5. If it's an 8, they're a pair adding up to 7. But this digit would be the other one from 8 or 9. Is that interesting? I don't know. It feels like there's definitely something to be said for pursuing this line of inquiry a bit. So maybe it would be easier to rule 9 off that. The trouble is, just that would put 9 into one of these positions. I can't even claim that this isn't 9, because all that would need to be so is a 1, 3 pair here. And that seems feasible. Oh, 5, 8 pair has ruled out 5 from that cell. I hadn't seen that. I don't think it does anything in the column or the box. But we might as well note it if it's there as a thing. This 2 or 3 digit can't be in these cells, so it must be in one of those two. If that was a 1, these two would be 1 and whatever that was. And this would be a 1, 2, 3, 4, 5 chord, and that would have to be 8. These would both be from 9, 6, 7. And again, it would be interesting, but Can't quite see how it solves any of the puzzle. Oh, 1 and 3 are looking at this cell. Oh, don't tell me I'm going to have to colour 4s and 5s now as well. I feel like I've been colouring throughout this puzzle and always different things and always getting different results. Oh, hang on, I've accidentally taken 5 out of all these cells. I don't know how I did that. It's certainly in one of them. I think I had those highlighted when I was saying 5 couldn't be there, perhaps. Yeah, that was foolish, but at least I spotted it. Right, is this isn't a quad. No, we've got one more from 1, 3, 4, 5 to go in these cells. Is it to do with these orange and light blues? I think it is a fact that I can't exclude all of the higher digits. At least one of these is red or light blue. If that was red, this couldn't be red. That's just not doing anything. Oh, 2 in this row. Oh no, I've forgotten this cell. It's either on this line or this line or this line. That's quite interesting that 2 has to be on a line in this row. Actually, maybe that is a general point. All of these cells, I just can't be adding up all of these lines and measuring them against each other, can I? I don't think so. But it's not an impossible way to go about the problem. Right, there's a 4 there, so this can't be 4. 6, 7, 4, 9 in this column. Everything else is from 1 to, oh, these two see 5, 8 as a pair as well. So they're from 1, 2, 3. And that one can't be 2. So that digit is definitely 1 or 3, which is definitely pretty low. This 5, 8 pair, if that's an 8, that's an 8. But if that's a 5, this is 5, and that's 5. What happens to 5s then? Let's just have a quick fling with the 5s and see if that yields anything. 5's in one of those, it's in one of those, one of those. Oh, that would have to be 5. Then it would be in one of those 3. And one of these 3, so it would have to be here. I don't know. It feels quite interesting without being conclusive again. I mean, there is the other issue that 2 is definitely in one of these 2 cells. And if it's here, one of these 2 is a 2 and is constraining their line pretty hard. I don't think putting a 1 or a 3 on a 4-cell segment that's adding up to 15 is particularly powerful. It is powerful. No, it's that digit that's powerful. This cannot be a 9 anymore because those have to be 1, 2, 3 in that case to add up to 15. And they can't be, or this cell breaks. So this digit can't be 9. And this is where 9 goes. And now we do get the situation that I wanted in a way, where 8 and 9 are in these 3 cells. They certainly can't both be on the line because then it would add up to 17 plus. So one of them is there and the other one is on the line. Now this digit can't be a 7, or we'd have 15 at least for 2 cells and 1 cell to come. For this to be a 6, we'd have to have an 8-1 pair here. And that would have ramifications. We'd have 3, 4, 5 and a 6-7 pair out here. In fact, what we've now got, right, those 3 add up to 22, plus the green line, the blue line here, which is 15, that's 37. These two cells have to add up to 8 to get us to 45. The magic total of every row, column and box, a secret we sometimes share with you. Right, so if those add up to 8, and this is 1, 2 or 3, this has to be 5, 6 or 7, and that is now a triple in this column. It almost feels worthy of some colouring. Oh, this digit can't be 5 because we've got a 5 in the box. So that's a 6, 7 pair, and this digit is 5. And now I can colour this dark blue. And these two definitely add up to 13 and need a 2 to complement them on the line. And that digit is a 3. So then we take 2 out of this cell, 3 out of all of these. One of these two is a 3. Does the colouring get us any further? It makes that corner a blue. Oh, you know what? That doesn't do anything else. But that is 6 or 7, and these two added up to 8. So this one can't be 3 anymore. So 3 is definitely on this line, along with 6 or 7, yellow 6 or 7, which has to be there now. Feel like that's interesting. Does that stop this being a 2? No, they're 8, 5 then. But 4 is in one of these two cells at least, along with 1 or 3. I know it's not 2 because of that. 4 is in one of those cells, so it's not here. Nor's 5. This is 1 or 3. Oh, was this 9, 1, 3 was a possibility here, but the 1, 3 were down this column, so that's all right. Now, 6, 7 up here. How am I going to use that? I can't convert it into blue and yellow there. It hasn't translated into red and orange at all. And maybe this trail is going to peter out frustratingly here. Now, can either of these? We know they're not high. If that was a 2, these two have to add up to 13, and they would be 8 and 5. Okay, let's try it at the other extreme. If that was a 6, these two add up to 9 without using 6 or 7. Or they would have to be 1, 8. Well, that's interesting. 9 hasn't been available either way round for this being 2 or 6. Is that right? I think that is right. No, it's probably not right. If that was a 2, this could be a 9, 4 pair. I don't think there's a problem with that. I've just done my maths wrong. Botherations. This digit sees 9, 8, 3, 1. It's on a 13 line. A 13 line that is going to have a 6 or 7 here, unless this is a 6. Then these would be at maximum 4, 3. And this would, okay, if that was a 6, these are maximally 4 and 3. And that is minimally 6 itself. So if that's a 6, this is a 7. And there'd be my fabled yellow and blue. And they would end up down here as red and orange. And they'd be off this line. Oh, this is getting complicated, even more than it has been. I thought it was going to be, oh, this digit can't be. I thought it was going to be really helpful to have the 8, 9 pair here. I thought that was going to resolve things, especially when I found I could find yellow up here. Okay, for 4 to be on this line, there are implications there. Then, well, in fact, actually, what am I doing? I seem to have written 1, 3, 4. Yes, none of these can be a 2. Why had I not seen that? This is the only place for 2 in the box. These are 1, 3, 4. They add up to 8. And this line adds up to 15. So yellow is a 7. Ah, ha, ha. Ha, ha, ha. Mwah. Here we go. So dark blue is a 6, and we can get rid of those colours. And now, some line somewhere is addable. Isn't it? Is it really not still? It hasn't changed anything anywhere else. Okay, that's maddeningly annoying. These are from 1, 2, 4, 5. That hasn't solved the puzzle. I thought that was huge. This is what Half-Baked is doing to me today. This can't be a 2. And that's pushing up a little. This is now 4, 5, 6, or 7, making these maximally add up to 9, with that at the minimum. So these add up to somewhere between 6 and 9. Still doesn't prove whether this is 2 or 6. What we do know now is that one of these 3 digits is 2. Oh, it's not that because of this. So either that's a 2, and I think then this pair has to be 8, 5. And that's a 9 in that case. So 2, 8, 5, 9 would be gone. These would add up to 13 from 7, 6, 4, 3, 1. And I think that would have to be 6, 4, 3. So that's one possibility of how this line ends up as a 3, 4, 6. If that's not 2, this is a 2. And then these two have to add up to 11. And this can't be 7 or 6. So this is 7 or 6. This would have to be a 4. And now I know that there has to be a 4 on this line, because it's either 3, 4, 6 or 2, 7, 4. This can never be 5. It either goes 2, 7, 4 or 3, 4, 6 in some order, which doesn't have all that many possibilities. And there's some digit that has not appeared, is there? In the various possibilities, I know 2, 5, 8 or 2, 7, 4. Now, come on, we're getting there now. That digit is 3 or 4, and this is a 1, 3, 4 triple. And that can't be 3, and this can't be 4. And this has become a 2, 6 pair. So this digit can't be 6. This is either 4 with a 3 there and a 6 there, or 7 with a 2 there and a 4 there. This is weird how this is shaking down. Oh, that 2, 6 pair is going to sort out at least 7 and 6 this side. That does nothing else, as I keep saying again and again. One of these digits is a 1. That's not any use. 2 and 6 as a pair. Right, if that's a 6, yeah, then these are 8 and 1. This is something I did earlier. If that's a 6, these have to be 8 and 1, because one of them has to be high. If it's a 2, I think these had to be 8 and 5. Well, now that we know that 4's on this line, that's right. I don't know if it was right before, but it is right now. These are either 8, 1 or 8, 5, and there's definitely an 8 in them, and this digit is a 9. And that one isn't. Okay. Now, 9 down the central. That can't be 9. So this is not a 9, 1, 3 triple. There is an 8 on this line, therefore, because the grey has to be a high digit, and grey is 8. And now light blue is 9. And this is either 823 or 814. I don't know which. But I do know that one of these is a 9. I can get rid of my colouring of light blue and my colouring of grey. And one of these is an 8. Okay, so does that make something like this particularly helpful? No, it really doesn't. Okay, this is either 841 or 832. If that was a 9, these would have to add to 6. Well, that couldn't be 841 in that case, because the 9 would use either a 1 or a 4 on its line with 1, 5 or 2, 4. If instead this is not a 9, then this has to be a 6 or 7. There's a lot of possibilities there. If it's a 7, these add up to 8. They're not 7, 1. They couldn't be 2, 6 because that square can't be either. So if that was a 7, these would be 3, 5. And that would be 8, 1, 4. If this was a 6, these would add up to 9 and not be 6, 3 or 8, 1. Or 2, 7 because that can't be either. They would be 6, 5, 4. And then this would be 8, 3, 2. But that has left all of those possibilities open. So I have to do a little bit more. I have to find something else by Sudoku or something. Which is annoying because I'm so close to cracking this. I'm one deduction away now. Let's get rid of that colour of pink. It's not doing anything anymore. And I might need to colour something else, of course. So I maybe threatened at one point to colour 4, 5. So let's go violet and green. Violet there. One of those two is violet. Yes, violet is looking at those two. So violet will have to be in one of these. And then it could be anywhere here. That's, I don't know, that's not really doing anything, is it? 4, 5 up here. I can't rule it out of that cell. And we can't rule it into that cell either. Wow. Oh, 9 in this column. 9 in this column only has one place. Oh yes, look, those two can't possibly be 9. So 9 is here. I think that was the light blue colour at some point. I'm going to get rid of light blue. Right, so now 9 is on this line. This is either a 5-1 pair to get to 15 or a 2-4 pair. Don't know the order, but 1 or 4 is in use. And this now has to be 8-3-2. And I think we know the full order. That's a 3. Yes, we do. That's 8, and that's 2. Here we go now. That has become a 4, so this is 7. This line adds up to 13. It's the inner line, so that's a 2. That's a 6. That needs 8 and 1 up here. And now we're going to finish the top row, and I think we're going to finish the puzzle. Thank goodness, because this has teased me throughout. That's a 4-5 pair. Oh, I could colour those in my new scheme, couldn't I? Why not? And these two, well, this one's a 3, in fact, and that one is a 1. And then as we come down this column, we need a 3, and that's in the corner. That's 3 in the corner. That's 3 in the spotlight, proving its position. This is a 1. That's a 5. That's not coloured. This is the coloured 6 or 7. Still don't know which one it is. This one sees 6 and 7, so that's not coloured, and that one is. Don't know how they get disambiguated by these pairs. How long have these been available? Don't know, don't like to think about it. Probably a while. Right, thank you, red and orange. You did your jobs as well. Colours, wahey. This is a 4, that's Sudoku. and therefore violet is a 5, and therefore green is a 4, and therefore we are going to finish Half-Baked Lunatics puzzle. Oh, how did I not get rid of the colours there? Did I slap some wrong digit in a cell by mistake? I don't know. 5, 4. These are 1 and 2. These are 1 and 8. These are 5 and 8. This 1 and 8 pair must be done. That does the 5 and 8 pair. And then we've got 5 and 3 to finish off. Lovely puzzle again, just as you would expect from Half-Baked Lunatic. Beautiful puzzle, beautiful solve throughout, just some long lines, but absolute joy. Thank you so much for watching, and do join us tomorrow night for the stream at 10 p.m. our time. It'd be lovely to have you with us. Bye for now.